What is inferential statistics? The fundamental idea of inferential statistics is to draw conclusions about a population through a sample. But before I unpack what that means, you have to understand what a target population is and what a sample is. In any research endeavor, we have something called a target population or a population of interest, which is simply the group of people we are interested in studying. For example, suppose that we wanted to determine how many hours students spend exercising on a typical week at the University of Hokkaido. Our population of interest would consist of around 18,000 students, which is the total enrollment count or the total student body at this particular university. Okay, so our target population is the group or collection of people we want to study. There is one big problem though with our population of interest. It's way too big. We can't collect exercise data from every single student in our target population of 18,000 people. That would be infeasible due to costs alone, and the time it would take to collect such data would take too long. Most research endeavors face this problem. The population of interest is too darn big. The workaround, however, is fairly simple. We collect exercise data from a sample of the population. A sample is simply a smaller, more manageable subset of the population of interest. We infer or draw conclusions about what's going on in the population through what we find in the sample. I mentioned earlier at the University of Hokkaido, there are 18,000 students. I want to know how many hours students spend exercising on a typical week at this university, but I can't and don't want to ask all 18,000 students about their exercise habits. So, I collect data from a sample of, let's say, 1,000 students instead. The data on such students might look something like this. From this sample data on 1,000 students, we can calculate things like the sample mean, which tell us how many hours on average students spend exercising on a per week basis. Let's say that our sample mean turns out to be 3.2 hours. What this means is that, in our sample, students spend 3.2 hours per week exercising on average. Now, remember we are not interested in drawing conclusions about our sample, which only consists of 1,000 students. We want to say something about our population of interest, which consists of 18,000 students. So how can we do that? Well, this sample mean of 3.2 hours can act as an estimate of our population mean. Therefore, from our sample data, we estimate or infer that the average student at the University of Hokkaido spends 3.2 hours per week on exercise. Notice how I'm making a conclusion now about the average student at the University of Hokkaido as a whole. I'm not talking about the sample anymore. We are effectively generalizing what we found in the sample to the entire student population. We actually do a similar type of generalizing quite often in real life. For instance, imagine that a pickup truck cut you off on the highway. You might generalize from this one dangerous occurrence that all pickup trucks are aggressive on the highway. Of course, this is an erroneous generalization, since your sample size is too small. It's just one occurrence. But I think you see the point. We generalize about the whole from partial information. A couple of more important points. The sample mean of 3.2 hours is not a perfect estimate of the population mean for obvious reasons. We are inferring something about a population of 18,000 people from a sample of 1,000 people. There is a degree of uncertainty as to how precisely our sample mean reflects the true population mean. This degree of uncertainty is often presented as a confidence interval, which I won't go into detail about now, but the takeaway message is this. In inferential statistics, we are inferring something about our population from a much smaller sample. As such, there is always a degree of uncertainty regarding our findings. That is why it's important for research findings to be replicated by other researchers, and you should be cautious of interpreting research results that don't indicate the degree of uncertainty inherent to their estimations. The second point I wanted to mention is that this inference from sample to population only works well when certain conditions are met. Most notably, the sample should be representative of the population. This is sometimes referred to as a random sample as well. This is something that will be covered in later videos. By the way, the mean is often described as a descriptive statistic rather than an inferential statistic, but it can be both. The key difference is in its application, or how it's being used. When the sample mean is used as a descriptive statistic, it is simply being used to describe or summarize the characteristics of a pile of data. When the sample mean is used as an inferential statistic, it is being used to infer the characteristics of the population. You can often distinguish if the mean is being used as a descriptive or inferential statistic by examining if a confidence interval is provided to indicate the uncertainty inherent to the mean estimate. If the degree of uncertainty is communicated regarding the estimate, the mean is most likely being used as an inferential statistic. Okay, that's it for now. See you next time.